Hi, welcome to the third part of the SMART tutorial. So in this video, we're going to cover the registration process. So in the last video, we went through alignment of the reference templates using the choice game. And we also learned how to plot the interpolated alignment with the brain morph function. So here we're going to cover two functions, or we're actually going to cover one function in depth, and I'll briefly explain the registration2 function. So the registration2 function is actually built on top of the original registration function in WholeBrain, except it just adds a interactive user console to the original registration function. And this is used for a single coronal image. And you can see almost all of the arguments for this function are the same, except this function applies, let me pull up this interface. It applies this user interface on top if you want to modify anything in your registration. So it makes it very, very simple to correct anything wrong in your registration or revert back to a previous registration change. And so the regiloop function actually calls the registration2 function in the SMART package, except this one goes further and actually automatically loops through every single one of your atlas slices for you. And so this will make it very simple to go through and manually correct all of the registrations in your data set. So you can see that there's only one, there's actually two required arguments. One is setup and the other is filter. So if you don't know what filter is, I would recommend you go through and watch some of the original WholeBrain tutorial videos. And they're also defined, the filter parameters are defined on the SMART tutorial website. So here's a brief explanation of what the filters are according to the WholeBrain documentation. But here, well, basically you enter in different kinds of parameters for what you want to segment out of your feature of interest. So your filter in the registration portion is actually used to detect the brain contours. So we've already created one. I'm just copying and pasting the code off of the SMART tutorial website. We've already created a filter optimized for this data set for registration. So this is the other thing. This is the one other argument that is necessary for the regiloop function to work. So I'm just going to create that really quick so you can see that there's basically very few variables we have are set up in the filter parameter. Actually, you know what? I'm going to remove this. And just for simplicity, I'm going to actually name this the auto fluorescence filter, or the GFP filter. So I'll call this GFP filter because there are different parameters used for the segmentation portion in the FOSS filter. Okay, so before I run this, it's always good to look at the help page. And I want to point out a couple special arguments. So if you run this as is with all of the defaults, the regiloop function will loop through every single atlas plate coordinate. So it will loop through, if we go back in our history, well, let me just show you. In the setup filter, go to regAP, it will loop through every single one of these coordinates. And it will go through and present the interactive console for you to manually correct each and every one of those. There's also a auto loop argument that allows you to, so when this is set to true, the default is false, instead it will automatically loop through every single one of these plates for you and skip the manual registration part of it. And so it won't present you with the interactive console. Okay, so I actually recommend everybody go ahead and first run this function with auto loop as true, even though the default is false. Because, so, oops, what am I doing? So we're gonna run it really quick. We're gonna set the filter equal to the GFP filter. So I recommend you run auto loop with true first, so you can actually just see how a whole brain does at registering all of your images with your specific filter parameters. So there's bound to be some amount of manual correction that you need to do, but the point of this is you can look through and scroll through, all 70-something, this is about 70-something coordinates, 70-something plates, and look at the ones that really need manual correcting versus the ones that don't. So that's what the point of the auto loop function is. And you can see that in the details, there's actually no return value created. There's a variable that will automatically be created in the global environment when you run this function for the very first time, and that variable will be stored as regis. That stands for registrations. And so you don't actually need to set this with the operator, with the storage operator in R. So you can actually just run it as is like this. So let's see what it looks like when you run this with auto loop. So yeah, you can see that it's basically looping through your entire data set. And so let's just take a look at the output and where this is saving to. So if we go to our output folder, this is example output folder, and we go to registrations auto, you can actually see that the registration output is being saved over here, right? Okay, there's some mess ups you can see over here. There's some things that are wrong, but some things that look all right. And you can see the latest one. It gets better in the middle. Again, some atlas plates for some reason are a little off, and they require a little more manual correction, like this one right here. Okay, so basically this will loop through all of your atlas plate images. It won't take too long. I believe it takes like 40 minutes or so. So at this point I would walk away, get a coffee, and wait till the auto loop is done. Okay, so the auto loop stopped running, so you can see that 25 minutes have elapsed. So the perfect amount of time for a coffee break. But yeah, let's get started again. Now that the auto loop is done, you can see that we have a new variable in our global environment that's called regis. Regis is an optional argument, but once it's created, you need to set regis as an argument for a call to regi loop for any subsequent function calls. So, for example, if we don't set it, let's just try calling regi loop right now. You can see that you're going to get an error, and that tells you, oh, please set regis equal to the regis argument. So we're going to do that. Okay, so after the auto loop's done, we can actually go back and check in the auto registrations folder. We can see all of our registrations, and you can see, the general quality of them, right? We can loop through all of them and see, well, it does a pretty good job over here. There's some things that aren't completely matched up right here, but for the most part, it looks decent. Okay, that one's not great. Yeah, we definitely have to fix up that one. But there's it does a decent job. But there's a lot that needs to be fixed up. So that's what some of these other arguments are for. So I would actually first go through, once you're done with the auto loop, and make a list of all the ones that you really want to fix up. For the most part, this slice looks okay, so you might want to skip it. But you can actually, once this is done, you can actually go ahead and set the reference argument. If you set the reference argument to true, right? And we run this function, we can actually correct just the reference templates that we aligned in the choice game. And this function will automatically just loop through these templates and let you automatically correct for them. And you can go ahead and see that, okay, yeah, this one needs a lot of correction. When it's this screwed up, normally what I would do is I would go ahead and just delete all but one of these points, and then go ahead and manually add all of the rest to really get the registration really nice. So let me first demonstrate that for you. So you'll see you'll get this pop up, and on the right, the purple lines represent how the atlas has morphed to the contours of your image, and on the left, the yellow lines are what the actual vectorized atlas plate lines look like. And so you can see that it hasn't done a very good job warping. And also, one other window has popped up, and this is just the raw image file underneath all of this. So this is just here to just give you a better sense of the features in your autofluorescence channel without any of the atlas lines superimposed on. So that can be helpful sometimes when you want to compare to, let's say, the PDF atlas right here. Where is that? When you want to align to the PDF atlas. For some reason, that's not showing up. But when you want to take a look at the atlas. So let's go ahead and correct this one, and I'll demonstrate the interactive console for you right now. So I would press R for remove all the points. So you can actually index using R's sort of colon, R's colon to indicate which points or which point ranges you want to get rid of. And I'd say I want to get rid of points 2 through 30. Right? 2 through 32. I meant 32. Okay. And you can see that we're left with just 1 point now. Okay, so let's try out the other options. We can add some points. So let's enter A for add, and let's add just 4 points, right? And so you'd want to begin with the target image on the right and then add the same point to the left. So these are the original instructions in WholeBrain. So we add, let's add a point here and then add it to the corresponding point in the atlas. Let's do the same thing on the other side. I like to keep things pretty even, so if I do something to one hemisphere, I like to do it to the other. Let's add a point at the bottom here. Okay, and you can already see that looks way, way better. So if you add, let's add like 2 more. Say add. Or, let's add 4 more. And see how that looks. Right? And again, I'm trying to keep even. Okay, and it looks a little better. At this point, I'd probably delete point 1. So let's try the, oh, we already tried the delete function. Okay, well, let's just do that. Remove. Let's just delete point 1 because it'll look better that way. Okay, and you can see that our registration looks like pretty good now, right? Let me demo what it's like to just not delete a point, but actually just change it slightly. So if I want to say shift 0.6 up slightly to the right, just because it's not quite exactly where I want it, I can do that by using the change function, or entering C for change in the interactive console. So which point do I want to change? I want to change 0.6. Change 0.6. In the target image only. So that's on the right. So change on the target image only. Let's say that it should be over here. slightly to the left of where it used to be. Okay, you can see that, okay, it messed up a little more on the side, but we can add another point for that. Or if we thought the previous registration was better, before I just made that change, we can demo the revert to previous change option. So that's Z. So if we press Z, we can revert back to our previous change. Okay, and yeah, I know this part is a little messed up, but let's say that we like it. Okay, so it goes back to what we had before, and let's say, oh, we're pretty happy with this and we're finished. So let's press F for we're finished and we like this registration. And then you have the option to save the global environment. I would recommend saving it because after all of these interactive changes, the Reggies object or the Reggies variable is actually being updated as the interactive console is running. And once you're finished with one, you definitely want to save it. But the more registrations you do, the longer it will actually take to save your Reggies variable. So if, for the sake of time, it might be easier to do, 3 or 4 plates of manual registration correction and then saving the global environment just to save time, because it does take a little bit of time to save the global environment. So you can see that it's taking some time now. Okay, so it finished saving. So it's loading up the next reference plate. And you can see that in the console, it'll tell you that you're starting a new registration and that is successfully saved. So that just means everything's nice and updated. Okay, and you can see that this registration looks, better than the last one. It looks pretty good. But you can add a couple correspondence points internally to line up some of the internal structures right here. And so this just demonstrates that you can loop through and manually correct the reference plates. And I'm just going to press escape now in the console to exit out of the reference option, because I want to try something else and demonstrate to you that we can also set up which exact plates we want to manually correct using the touch-up function. So that's right over here. The default is to set touch-up to false, but if you set touch-up equals true, you will actually get a console interface that tells you to manually enter which plate you want to manually correct. Or you can alternatively, instead of setting touch-up equal to true, you can enter a vector of integers like, I believe you enter a vector of, the plate numbers that need to be manually corrected. And so what I mean by plate numbers is every registration gets saved with the plate number, the AP coordinate it corresponds to, and the Z image from your data set that aligns with that AP coordinate. So it's easiest to touch up based on the plate number rather than entering in the AP coordinate, just because it's a simple integer that you can enter into a vector. So I would go ahead and record down which plate numbers that you want to manually touch up, and you can enter it as like a vector here of integers. So let's just say, let's scroll through. I don't know why I added that. And let's pick a couple that we do want to manually register. Okay. So let's just say, okay, plate 44. Let's enter that in, right? and plate 51. Yeah, let's just enter those two, okay? So it'll automatically loop through these plates, okay? So let's run that. Okay, you can see that this pops up along with the raw image. And so we'd want to manually correct for some of these points that are off. So everything, to be honest, looks a little shifted by, slightly to the left. And rather than try and shift every single one of these correspondence points slightly to the right or slightly more clockwise, I'm going to do that strategy where I just delete all of the points but one. So I found that works pretty well. So let's just say remove. And I want to remove points 3 through 32. By the way, if you want to remove a subset of points, right? Like, for example, 2 through 7 and then 18 through 23, you can absolutely do that. You can just do 2 through 7 and then comma, enter 18 through 23. So you can be very specific about your correspondence choices in the console. So, but let's just enter 2 through 32. Okay, so we've deleted all but one, and let's just change point 1 where it is so that it matches a little better. Okay, it's over here in the atlas, so we want it sort of right over here. Okay, so it hasn't worked very well, but that's only because we have 1 point. So we're going to want to add a whole bunch more. Let's add like 6 points. I wouldn't recommend adding like 12 because honestly, I just get confused and I forget which side I've clicked on first, and it completely screws up the warp sometimes because it's just too many points to keep track of. So I normally don't add more than 6 at once. So let's add, 1 over here, right? Okay. And you can see that looks pretty good. In general, I probably shouldn't have added those internal points first because I would recommend adding some points along the contour, but you can see that the internal snapped into place pretty nicely. So I would actually just basically interpolate this out and add some points along the contour and really just stretch this out nicely. You can see it already looks pretty good. So I'd add maybe, let's add 6 points. Yeah, that looks pretty good. I'm just going to add maybe, 4 more points on the bottom, but I think after that, this is good to go, right? Okay, that kind of screwed up there, but for the sake of this demonstration, actually, no, I really don't like it. I'm just going to remove that 1 point. All right, good enough. I mean, it's off right here. That pains me. But let's just say we like it and we're finished. So we just press F for finished. And then we'd save the global environment. I'm not going to because it took a while last time. But basically, you can see how simple this is. And it's pretty simple using this interactive loop to manually correct for all of the registrations across your entire data set. Okay, in the next video, we're going to go over the segmentation process to loop through all of your images, and not just the images that correspond to the atlas plates, but all of the images in between atlas plates too.